In the heart of every city, a silent workhorse hums day and night, dealing an hour with illuminates everything but silent.
The Ncinerator, marvel of engineering, symbol of progress, the cause for concern. As we strive for a cleaner, safe environment, the need for effective emission control has been more pressing.
The impact of uncontrolled emission is indictable, designed to rewrite the narrative, to innovate, and to pave the way for a sustainable future.
Today, we stand at a precipice of change. Join us. We explore the cutting-edge technologies, the breakthroughs in emission control, and the transformative power of responsible waste management.
Welcome to a presentation that will ignite your imagination, spark conversation, and shed light on the path to a greener tomorrow. Welcome to Burning Bright, revolutionizing incineration and emission control. Generally, when we talk about incinerator, we'll be thinking about furnace that used in the process of burning and solid waste for the purpose to reducing the volume of waste by removing combustible matter. Well, based on regulation 1 to 9, commercial and industry solid waste incinerator units, this operation must be done properly, aims to reduce pollution and protect public health and the environment. So, how this process occurs? Besides, the incinerator process involves the combustion of waste materials at high temperatures, typically in the range of 850 to 1000 degrees Celsius, to break down organic and inorganic molecules and reduce the volume of waste. So, the process requires three essential components for combustion to occur: a fuel to be burned, a source of oxygen, and a source of heat. When waste is introduced into the incinerator, it enters the burning chamber in a controlled manner. The waste is dried to facilitate its volatile properties, and then the high temperature flame zone of a well-designed incinerator breaks down the waste to allow reactions between most organic and many inorganic molecules. The combustion process releases heat energy and exhaust products, and it can be controlled or stopped by regulating the amount of fuel available, the amount of oxygen available, and the source of heat. So, the proper incineration of contaminated material is important for preventing and controlling exposure to harmful substances, and it requires temperature of over 850 degrees Celsius, with even higher temperatures needed for the destruction of large amounts of contaminated material.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Taufiq, and now I will present about the types of incinerator. The first one is burn pipe incinerator. It operates by providing a controlled environment for the combustion of organic waste such as leaves and branches. It typically constructed with metal rings or walls. The incinerator allows for contaminants of materials as they undergo ignition and subsequent combustion. Adequate water flow facilitated through openings of vents, such as a hot burning metal into ash, water vapor, and carbon dioxide. The next one is pyrolysis chamber incinerator. It employs a process known as pyrolysis for the controlled thermal decomposition of waste materials. Organic substances are heated in the absence of oxygen, causing them to break down into volatile gases, liquids, and char. It is designed to be more efficient and environmentally friendly than traditional open burning methods, as they minimize the release of pollutants and can potentially recover energy from the process. The third one is rotary fused incinerator. It operates by subjecting waste materials to high temperature in a rotating cylindrical drum. The waste is fed into one of the kilns, and as the drum rotates, the intense heat generated by the combustion process within the kiln causes the waste to undergo thermal decomposition and oxidation. It involves the conversion of organic materials into ash gases and other byproducts. The fourth one is single-chamber incinerator. It functions as a self-contained unit designed for the combustion of various waste materials. The waste is introduced into a single combustion chamber, and the combustion process serves to break down organic matter, reducing it to ash and other byproducts. It is used for the disposal of non-hazardous municipal waste, medical waste, or other types of solid waste. The fifth one is drum and rig incinerator. It is a simple and traditional waste disposal system consisting of a cylindrical drum and surrounding rig structure. The waste materials are placed inside the drum, and a control fire is initiated within the rig enclosure. This approach is cost-effective, but it may lack advanced control mechanisms, which potentially leading to incomplete combustion emissions. The last one is fluidized blade incinerator. It operates by suspending waste materials on a bed of inert particles, typically sand or other granular materials, within a combustion chamber. The high temperature in the fluidized blade incinerator facilitates the complete breakdown of organic waste into ash and other byproducts. It also offers advantages such as enhanced heat transfer, reduced emissions, and the ability to handle a variety of waste types. It is particularly effective in treating hazardous waste and is known for its energy efficiency and environmental performance. Thank you.
Hi, my name is Ahmad Shah bin Azahar and my ID number is 2023168721, and I will continue our presentation about poster. So, ladies and gentlemen and lecturer, today we come together to explore the forefront of environmental stewardship and dive into the crucial realm of emission control technologies. As our world grapples with the detrimental effects of air pollution, it becomes imperative to adopt effective measures to mitigate the release of pollutants into the atmosphere. The primary sources of these pollutants, vehicles, factories, and power plants, underscore the urgency of our mission to safeguard both the environment and human health. Let's shine a spotlight on some of the most prevalent emission control technologies that play a pivotal role in curbing air pollution. Scrubbers act as environmental custodians in industrial settings, removing harmful gases and particles to ensure that only clean emissions make their way into the air. Night 6 baghouses, as stalwart guardians against the particulate matter, utilize advanced filtration system to capture and trap airborne pollutants, preventing their escape into the atmosphere. Catalytic converters champion vehicular emission control by facilitating chemical transformations in exhaust gases, significantly reducing the emission of harmful pollutants. Allotropic precipitators, which is ESP, pioneers the electrostatic technology, attract and capture particulate matter through electrical charge, offering an efficient solution for both factories and power plants. Gas absorption system and employed in diverse industries utilize liquids to absorb and neutralize pollutants, ensuring that emissions are cleansed before release. Selective catalytic reduction, which is SCR, a technological marvel in power plants, promotes chemical reaction that selectively reduce nitrogen oxide emissions, a common byproduct of combustion. In a world where consequences of air pollution are becoming increasingly evident, these technologies stand as beacons of hope. By implementing scrubbers, baghouses, catalytic converters, allotropic precipitators, gas absorption system, and selective catalytic reduction, we pave the way for cleaner air and a healthier planet. Let us collectively champion this innovation and work towards a future where the air we breathe is free from the shackles of pollution, ensuring a sustainable and vibrant world for generations to come.
Assalamualaikum and hi, my name is Ncinerator from S229-2B and my ID is 20231049 and 63. For my part, I will continue about the benefit and harms of incineration. I will start from the benefit first. So the first benefit was waste reduction. Incineration is controlled burning of solid waste material, converting into ash and gases, reducing heat volume and making it easier to dispose. Next is energy recovery. Incineration offers energy recovery through the combustion, generating steam and electricity through the turbines. Volume reduction also benefit to incineration because it is significantly reduced waste volume. Next, pathogen and toxic reduction. Incineration effectively destroys pathogen and toxic in medical waste, preventing disease spread and reducing environmental impact due to the high temperature and neutralization of toxic substance. And last but not least, incineration also can make more metal recovery, such as facility that use technologies such as magnetic separation to recover variable metal from ash, and it is for virgin material and contributing to resource recovery. So for the next part is for the harms one, and okay, so air pollution through the emission can harm the incineration. This is because incineration releases pollutants such as NOx, sulfur dioxide and VOC into the air, causing a poor air quality and respiratory health issue. Next, it can formation of dioxin and furans. Significantly, environmental and health risk for combustion of material is necessitating stringent control measure and advanced air pollution technologies. Next, it can harm our health, and we need to be more have concern because of incineration release pollutant, including particulate matter. It can harm and risk our health because of the communities, especially in residential or sensitive area near the incineration facilities. Greenhouse gas emission also incineration harmful part because of despite its energy recovery benefits and contribute to the greenhouse gases emission, release carbon dioxide, a significant concern in mitigation climate change. The last one was soil and waste contamination. Incineration, including ash, can contain harm substance leading to the soil and water contamination. Improper disposal can infiltrate groundwater, causing environmental and human health risks. So, in conclusion, it is important to note that incineration offers environmental benefit but also poses pollutant and greenhouse gases, necessitating advanced technologies to balance and benefit with environmental protection. And advancement in technology and strict regulation have mitigated incineration harm, but careful monitoring, proper waste sorting and effective pollution control measures are crucial for the minimizing environmental health impact. So that's all for me. Thank you.
Next, we dive into the intricate world of pollutants emitted from incinerators, shedding light on the diverse array of substances that pose challenge to our environment and human health. Lead, a toxic heavy metals, is released during incineration with potential severe health implications, particularly affecting the nervous system and cognitive function. Sulfur dioxide, a major air pollutant contributing to acid rain formation, is another concerning byproduct, posing risk to respiratory health and overall air quality. Mercury, a potent neurotoxin, finds its way into the environment through incineration, posing threats to aquatic life and human health. Dioxins, the furans, persistent organic pollutants, are also generated, linked to a range of health issues, including cancer. Particulate matter from incinerators comprises tiny particles that can penetrate deep into the lungs, causing respiratory problems. Carbon monoxide, a colorless and odorless gas, is released during the combustion of waste, with detrimental effects of the cardiovascular system. Nitrogen oxide, contributing to air pollution, is another byproduct of incineration. Acidic gases and various metals, including hazardous heavy metals, are released, posing risk to ecosystem and human health. Polychlorinated biphenyls, PCBs, and volatile organic compounds, which is VOC, further contribute to environmental contamination and health risks. This complex spectrum of pollutants underscore the urgency for implementing robust emission control technologies, such as scrubbers, baghouses, and catalytic converters to mitigate the environmental and health impacts associated with incineration. In striving for a sustainable future, we must address this concern to ensure that waste management practices are both efficient and environmentally responsible.